given that this song doesn't really have that much of an ending, I never know when to... Oh no, I'm missing in the corner! There we go. Much better. Hi there everyone, hi, welcome. Hold a bit of an all-nighter on ya. Hi! Hello and welcome to another live stream. Make it, your host. I stream every day, as I have been streaming for the past 559 days. Wow, I should really get live. Anyway, hello everyone and welcome to another live stream. They will be walking on the video, actually. That's what we'll do. We'll be walking on the video. Yeah, it's the breaking physics using math video. And I feel like we should just go straight into it. So, I have fully scripted the video. It's trying to tell us this. That's what could be collized with what we think that is. We break physics using math. Hi, the Vibu. Welcome. How you doing? How's your day going? I'm feeling weirdly energized considering that I just pulled an all-nighter and I had only 2 coffees. Something is off. I don't know if I'm about to crash or if it's just a good day for me. We'll find out in about half an hour. Oh fine, I won't be able to watch the stream. It is fine, I do stream every day, so you know. It's fine. I have a test. Ooh, what kind of test? Biden, Vivu, I suppose. Bye. Good luck on your test. Negative energy is going. Energy is negative. Maths calculus. Oh, good luck. That's a nice topic. Problems when our energy is negative. Full calculus. I mean, I believe in you. I believe in you. You need to believe in yourself too. You're gonna just wreck that test. I believe in you. Wreck in a positive way. Of course. And time, which isn't only negative, but imaginary? What kind of wackiness is this? Alright, and then we're gonna do the ending to the beginning thing, which I always like to do in my videos. So we're gonna copy this, and then we're going to go right here. So, what happens when our... It's negative? Depends. Is what happens when our velocity is faster than the speed of light. The speed of light. I should add this to the very beginning too. Speed of light. Well, then... Oh, music! I always forget about music. I'm so sorry. I always do forget about music, which is important, otherwise this live stream just feels so dry without music. It's just like me sitting here actually walking, so being entertaining? Ew. Am I right? I'm a YouTuber, I'm supposed to be a social parasite. I'm supposed to steal content and call it my own. And I'm just making videos like a nerd. There we go. Well, there we don't go. That's only one song when we want to play all of them. So, there we go. It's really quiet. Okay, I can see. Now it should be better, I think. There. Okay. Speed of light. Why is the velocity is faster than the speed of... Oh, actually, that's a good question. I think energy is. shucks, that is a good question. Yes. What happens when time? Negative, but imaginary? I really regret. I poured myself a glass of milk instead of coffee, because coffee gives me the, you know, the heart attacks for wimps. And I just thought maybe switching to milk would help. But it's making me tired. Or at least making me uncreative. Depends on what you think. No, it's garbage. I mean, I like the question-answer format. Because, you know, it would be nice to... We start the video with questions, we end the video with answers. Alright. Energy is negative. Tells us what could be, but physics tells us that it's not. When our velocity is the speed of light, math tells us go, but physics tells us we can't. And time is not only negative, but imaginary. Could exist as that doesn't. If I bring in physics into math works, math tells us what could be, if it's trying to tell us what is. And that's why when what could be collides with what we think that is, we break physics using math. And then explosion and drops microphone, does a backflip and all the things. Alright, let's do it. New item, sequence, of course, HD 1080 50 FPS, and let's call it breaking physics using math. And let's record something. The big drop, hell yeah. What happens when energy? I mean, let's try again. What happens when our energy is negative? When our velocity is faster than the speed of light, and time isn't only... This is not English. Hold on. This is... What happens when... This is not English. This is... What happens when our energy is negative? Our velocity faster than this... speed. Our velocity faster than the speed of light, and time not only negative, but imaginary. Okay, I got it now. I'm in the zone. What happens when our energy is negative? Our velocity faster than the speed of light, and time not only negative, but imaginary? Well, yes, all of those, yes, we'll get over all of these and more, believe it or not, in this video, but first, let's start the warm-up and ask a question of, why does math break physics? Okay, the process is simple. Well, let me make sure that sounds good. What happens when our energy is negative? Our velocity faster than the speed of light, and time not only negative, but imaginary? Well, yes, all of those, yes, we'll get over all of these and more, believe it or not, in this video, but first, let's start the warm-up and ask a question of, why does math break physics? Why does math break physics indeed? That's a phenomenal question, Make It. Thank you, Make It. I'll be glad to answer that question. Why does math break physics? Okay, the process is simple, but I'd really like you to understand how we're able to break physics using math. And for that, we'll use a light bulb. This light bulb, when we turn it on, it emits photons, or in other words, light. More photons, brighter light bulb. Less photons, lower brightness. Simple. We can represent the amount of photons emitted with a number, so this would basically be 1, this would be 7, this would be half, this would be 100, and so on. Now what we've done is we just abstracted a real physical thing into this number. A big word because it's kind of important for the whole process. Why is abstracting it important? Well, it's because now there's a number, we can do all sorts of things, like not only setting it to normal stuff like 1 or 0.5, but wacky values like 0, which gives us no emission, or -3. What would -3 mean? Well, for Blender it's simple, just darkness. A light bulb so dark it's sucking up all the light around it, but for real life, it doesn't make sense. And that's the point I'd really like to accent in this case. If this value is the abstraction of the amount of photons an object is emitting, then negative value wouldn't mean the object sucking in photons, or the object emitting antiphotons. No, this means the object emitting normal, ordinary photons, but a negative amount of them. That's the problem with abstracting. I always like to visualize it like this. If you have a problem with high level of complexity, if you abstract it and reduce its complexity... Nope, that's not what it says, make it. That's the problem with abstracting. I always like to visualize it like this. You have a problem with a high level of complexity, if you abstract it, you reduce the complexity and the accuracy. So relativistic quantum mechanics can be abstracted into chemistry, chemistry into biochemistry, which can be further abstracted into biology, medicine, and so on. The general rule being that you can abstract things in different ways. So for a light bulb, for example, we can represent the brightness using the amount of photons, the energy of photons, and the... Okay, well, for photons that's kind of it. But my point is, this isn't just a straight line, it's a cone. A cone in which the further you go, the more blurry things become, and you can only go forward. You have the starting theory, which is currently mostly relativistic quantum mechanics, and then you just move on, never going back. Based on relativistic quantum mechanics, you can create chemistry, but based on chemistry, you can't create relativistic quantum mechanics. Based on biology, you can't create medicine, but based on medicine, you can't create biology, and so on. That's not to say that you can't use the evidence from further down to support the start, only that cells dictate how the lungs should behave, not the other way. And that's what abstraction is all about. But this video, I don't just want to talk about this deep, meaningful topics, because that's cringe. In this video, I'd like to have fun. So let's have fun and do some wacky math for even wackier physics. So first, let's start simple, with something nice and easy, not too complex. How about relativity? Time dilation, to be exact. Here's an equation. What does it mean? It means that we have a cube number 1 moving forward and a cube number 2 observing it, then this would be the time of our observer cube and this would be the time of our moving cube. Now if our moving cube is traveling forward at 1 meter per second, let's take a look at what happens after 1 second passed for our observer cube. Okay, not surprising, we moved by 1 meter, I mean that's to be expected. What's the big deal? Well, the big deal is that if we insert our velocity into our equation, we get that whilst it was 1 second for observer cube, it was 1.00000000000000001 seconds, which is higher. It was 1.000000000000000000000. Am I counting 16? I feel like I'm not. I feel like I'm counting at the same time. It was 1.00000000000000000. No, damn it! Make it. Get it together. It was 1.00000000000000001 seconds, which is higher. Now, or in other words, time is relative. Time for cube number 1 is different than time of cube number 2. Now what's interesting in this case is that we could switch them around. That's actually kind of the whole point of relativity. If we establish the moving cube as stationary, that's the relativity moment. No, yeah, because moving cube is stationary, I get it's funny. then it's staying still and the entire world is moving away. So both of these cubes would perceive their own time as normal, 1 second per second, and the others as higher, 0.69 per second. 1.16 zeros and 1 per second. But how could both of these cubes perceive their own time as normal and the other one as higher? This doesn't make any sense. That's kind of like having two elevators in which the first one is higher than the second one and the second one is higher than the first one. Except, like, that's a contradiction, right? Well, not quite, and here's where the genius of relativity really shines through. Imagine if we take our elevators and we tilt them at an angle. Now if we move them up, let's see what happens from the perspective of the first elevator. And from our green elevator, we'll perceive the red one as being lower. From our red elevator, however, we'll perceive the green one as being lower. That's because both of them have their own relative height. Their heights are different based on where they are. The concept of height is different for each elevator, and for an outside observer looking at them in the middle, they would be both at the same height. For relativity is the same thing, except in this case the height would be analogous to time and the slope would be analogous to velocity. I'll make a full video about general relativity soon, just give me like a week or two, maybe 3 or maybe a month. And that by itself is already weird enough, but we can go further, because what if we're traveling at the speed of light? Well, physics tells us that you can't really, but we're here to break physics using math. So what happens if we... Well, physics tells us that you can't really, but we're here to break physics using math. So what happens if our cube, instead of moving 1 meter per second, moves at the speed of light? Well, first let's see what happens when the speed of our cube goes up. Right here I've graphed it in Desmos, and we can see that the velocity of our cube goes up. And we can see that as the velocity of our cube goes up, so does the time dilation. And in Desmos, and we can see that as the velocity of our cube goes up, so does the time dilation. And at the speed of light, well, if we plug in the speed of light into our equation, right here we get c squared by... Right here we get c squared by c squared, which is 1. And then 1 minus 1 is 0. And square root of 0 is 0, so... And 1 divided by 0, that's kind of infinity, which I mean it tracks. Now right here you may say something like, make it! How could... Now right here you may say something like, make it, but how could the time dilation be equal to infinity? This doesn't make any sense! But if you think that 1 second passing for a cube means an infinite amount of time passing for the other cube is weird, then just wait until you find out what happens when you go faster than the speed of light. Alright. How long is this already, by the way? 8 minutes! Oh, that's ridiculous! Hi there, Headstack, welcome. If you don't mind, I'm just recording a video in the background. I should be done in a couple of minutes. Now that's a hard rule, right? The universe speed limit, and physicists would be disappointed with me trying to accelerate the cube beyond that, but we're not here to do physics, we're here to do math, and thus let's plug in speed of light plus 1 into our equation. What we get is this, and once we solve it step by steps, right here c squared plus c squared plus 2, right, plus c. So right here c squared plus 2c plus 1, then c squared and c squared cancel, and we get 1, it's just 1, then y would then can go as y, and then we can go as y, because why would you care about this number? It's irrelevant, it's only constant, and we don't really care. The only thing that matters is that it's positive, a real number, and the two cubes, then 2 ones cancel each other out, and we end up with an imaginary number. Why? And that's because of how imaginary numbers work, we can just actually... And because of how imaginary numbers work, we can just bring it up with a negative, and if our moving cube is traveling faster than the speed of light, for each second it perceives the other cube I read that so incorrectly. I just now, only now I got it how I'm supposed to read it. Damn, oh, that's Well, I'm really bad at writing, apparently. Okay. Let's start right here. Well, what we get is this, and what we get is this, and once we solve it step by steps, right here, c squared plus 2c plus 1, then c squared and c squared can't change around, then we can call this y, because why would you care about this number? It's irrelevant, the only thing that matters is that it's a positive real number, and then two ones that cancel each other out, and then we end up with this. An imaginary number y? And because of how imaginary numbers work, we can just bring it up with a negative, and if our cube is traveling faster than the speed of light, for each second it perceives, the other cube gets a negative imaginary amount of time. Or in other words, if you will accelerate an object to faster than the speed of light, Nope, I don't even know how to describe it. Like, technically you achieved kind of time travel, I suppose, because the time is moving backward, except it's moving backwards in the imaginary axis, not the real one. So what would an object like this even look like? Well, no idea. No idea what imaginary time even is. So in case any of you ever wanted time travel, you know, I've got something even more ambitious for you. Breaking time as we know it. And now that I'm assuming the only... You know, I can do a better segue than this. Hi, the Cron Dark. Hi, welcome. How you doing? Antimatter but not antimatter? In what context? What do you mean antimatter but not antimatter? Hold on, let me get a sip. Okay, clearly we went too far. We broke physics too much. Alright, there's a reason why you shouldn't really accelerate things past the speed of light. So let's do something simpler, like negative energy. And how convenient, I just happen to have made an entire video about energy, so it's about time that we break them. Let's pick a couple fun ones like the radiant, gravitational potential, and kinetic. So first, radiant. What is radiant energy? Radiant energy can be described using the equation of E is equal to hc divided by lambda. So negative energy in this case would mean either, first, us living in a different universe where Planck's constant would be negative, second, speed of light being negative, or third, the wavelength being negative. Why did I write it as have to be? This is so annoying to read. Let's try it again. So negative energy in this case would mean either, first, us living in a universe... Alright, third time the charm. So negative energy in this case would mean either, first, us living in a different universe where Planck's constant would be negative, second, speed of light being negative, or third, wavelength being negative. First one was kind of boring. I mean, it just means redefining energy to negative and nothing changing. The second, however, is a bit more fun, because what would negative velocity even look like? Well, for now. I mean, you meant negative imaginary time. Yes. But how does that relate to antimatter? That's the kind of the point of this video. You have a lot of weird theories out there which end up becoming reality. But physics isn't really about telling us what could be, only what is. So when it comes to antimatter, we know antimatter exists, and that doesn't break physics as we know it, because it's a simple thing, just antimatter. But going faster than the speed of light does break physics because of the current equations we use to describe the universe. Am I explaining this point correctly? I don't think I am. I feel like I'm not explaining it properly. Well, I guess we'll wait for the video and see. Also, the conclusion of the energy chapter is a bit off, so... Negative velocity even look like? Well, it means that an object is either going a negative distance forward or going back in time. Now, mind you that negative distance does not mean backwards. No, it means forward, just a negative number of meters. If you go 1 meter backwards, that's still just 1 meter, just in a different direction. So going negative meters forward is not as easy as you think. Okay, what about time? Well, time would mean just traveling back in time, which, funny enough, if you turn around, you get... what... Well, time would mean just traveling back in time, which, funny enough, if you turn around, you get that... Such an awkward sentence, isn't it? Well, time would mean just traveling back in time, which, funny enough, if you turn around, you get that... No, I give up. I give up on reading that. As you accelerate, your mass energy increases. Approaching the speed of light, your mass energy goes to infinity. There is a lot of problems with going past the speed of light. Practically, it's not just the energy one. The energy one gives you the problem for why, like, we can't do it. As in, from a practical point of view, why we can't accelerate past the speed of light. But there is so many physical problems with going past the speed of light. All over relativity breaks. Every single energy is basically divided by an imaginary number. A bit late today. We're still doing some wacky maths. Yes, we are doing wacky maths. Hi, the Rukshan, by the way. Okay. Let's give that sentence another 7 tries before I get it right.
You get that.
Well, time would mean just traveling back in time, which, funny enough, if you turn around, you get that you would need a negative amount of energy to travel back in time. Mathematically, of course, not physically. And then the last and most shocking thing, which is negative. And then the last and most shocking thing, which is wavelength. And that's because negative wavelength could be the same as the positive, depending on how you look at it. Wavelength is just the distance between two things on the wave, two peaks, two zeros, whatever. Now, if you think about it physically, it doesn't make much sense. That's because, once again, what would negative distance be? Same thing as with meters, but mathematically, we do have an equation for cosine based on the wavelength, which looks like this, and we can plug a negative number. It's the same as the positive. So photons could actually have negative radiant energy. But that's boring. Next we have something cooler, potential gravitational energy, with the equation of... I forgot to plug in the equation in there, I remember it's negative. Yeah, I'm plugging the equation right here. Cool. That's a bit out of place, isn't it? Yeah, tachyons. But tachyons are hypothetical. Also, tachyons are wild. Tachyons are insane mainly because, like, okay, tachyons, the quicker they go, the less energy they have. Which means that if you have a tachyon with no energy, then it's traveling at an infinite velocity. In order to get a tachyon with no total energy, it would have to travel at infinite velocity. Which I find pretty cool, in my opinion. But yeah, once again, it's a hypothetical particle, so you know, whatever. Equation of... And I plugged in the equation in the wrong spot. Oh, I have so many this is gonna be so annoying to edit. Why am I struggling so hard reading? I can do quantum mechanics pretty well, but I'm struggling with reading stuff. U is equal to negative GMM divided by R. And what's really interesting in this case is that energy is already negative. And what's really interesting in this case is that this energy already is negative. It has a minus. Gravitational constant is positive, mass is obviously positive, mass is positive, displacement is positive, which means that if you multiply all of these positive values by a minus, you get the... No, that's not what it says, make it. Try it again. You almost did. Which means that if you multiply all of these positive values, you get a positive value. Multiply that by a negative and you get a negative value. So how could that possibly make any sense? Well, just as I mentioned in my energies video, energies are a bit of a fiction and an abstract concept. So energy being negative in this case doesn't actually break anything. You just set your level for 0 and then it's going up or down. A good example of how it works would be a ball with a ground beneath it. Now, if we let this ball fall, it will go down. That's because its gravitational potential energy just got turned to kinetic energy. And once it falls all the way down, it has no more energy to give. So right here, its gravitational potential energy would be equal to something like 1, for example, and right here, it would be equal to 0. But this presents a problem, because what if we dig a hole and the ball falls even lower? If this energy is 1 and this energy is 0, what's this? Negative 1? Well, yeah, gravitational potential energy can exist as a negative number because you set its ground level. Ground level is 0, anything else... I'm reading too quickly. Ground level is 0, anything else is relative. And then you only care about the change in energy, not the total. Mickey, do you think I could be a warp drive is legit? Oh, isn't that the warp drive where you can travel faster than light because you warp space around you? Is that the one? I don't remember my water as well. So it travels negative infinity meters per second again. No, the point is with velocity, you can't have it infinite because of how we defined it, basically. Yes, well, I think it's a cool concept. I don't know exactly how it would be done. I feel you would need exotic matter, correct? I think. Because if I remember correctly, it was like you had a dip in the middle of your vehicle, or whatever you want to call it, and then you have a peak, a gravitational peak back. But because, you know, masses are always equivalent, in order to have a peak, you would need negative mass, which would be exotic matter. Or is there something else? Waiting for the new Giga Chat make it, yeah. Next time so anyone calls you lazy, just say energy is a fictional and abstract concept. Officer, no, officer, listen, like, time is relative, okay? So, velocity, speed is relative. So I wasn't actually doing it 140 in the school zone, okay? Where you finish off? Anything else is relative, and then you only care about the change in energy, not the total. Alright, I see it. So when we dig the trench and we get the ball to fall down, so when we dig the trench and we get the ball to fall down even lower, whilst this energy would technically fall below zero, we don't care. It's more about how much energy we extracted from the ball. In this case, 0 and -5, or 5 and 0, or 70 and 65, it doesn't matter, it's just about the difference. But don't worry, there is still a way for us to break it. That stems from the fact that gravitational potential is a tool for describing gravity, rather than gravity itself. And that's because right here we have the distance, between them. And so we see that if we start digging the ball right here, what did I write down? Oh my goodness, am I having trouble reading or am I having trouble understanding? Zoom in, make it. Come on, you can do it, buddy. I believe in you. Alright. But don't worry, there is still a way. Are you ready? Oh, it's fine, make it. I'm good, everyone. Thank you everyone so much for asking. I'm doing fine. Okay. Let's give it one more try. Maybe 7 more tries would be in order. But don't worry, there's still a way for us to break it. And that stems from the fact that gravitational potential is a tool for describing gravity, rather than gravity itself. And that's because right here we have the distance between them. And so we see that if we start the ball right here and we let it fall, we're extracting more and more energy. How much energy? Well, if this is our gravitational potential, then the energy extracted is whatever we lose from it, or in other words, the negative of that. Which means that as we let our ball fall and fall and fall, at any point we can take the starting point and subtract the current value from it, and we get the amount of energy extracted. But something really interesting happens as we let it go on, and that's because R is getting smaller and smaller, and eventually approaching 0. And as it gets this close to the center of mass of our body, we get an equation which looks like this. As considering how we're going from the positive, this would basically mean that if we let our ball fall into the center of mass, we can get an infinite amount of energy out of it. It doesn't even matter how far we let it fall from. It's the fact that it goes to 0, not the distance itself, which gives us an infinite amount of energy. What? Why are we doing it then? Why didn't we already dig a hole into the earth and drop a ball? I mean, an infinite amount of energy, that's more than our solar system, or our galaxy, or possibly the universe. Just dig a hole, drop a ball, and all our problems are solved, right? Well, not quite. That's because here we once again broke physics using math, and we abstracted gravity into this nice equation, which simplified it a bit, but also lowered the accuracy. And that's because in order for a ball to fall into the center of the earth, there would have to be nothing in the way. But if there is nothing in the way, then what would be attracting it gravitationally? Instead of an infinite amount of gravitational potential, you would just get a finite gravitational potential from all sides, cancelling each other out. There is no such thing as center of mass. Center of mass is just a tool that helps us describe gravity. No, not gravity, mass. Whoops, let's try again. There is no such thing as center of mass. Center of mass is just a tool we use in classical mechanics to simplify equations. But in reality, each and every single one of this matter around our ball has its own mass. There is no center to speak of. But there is the third kind of energy, kinetic energy, which is much harder to justify as a negative. Photons could have been negative. Photons could have negative energy because of their energy. Photons could have negative energy because their energy has different consequences. Fine. Gravity has negative energy because its energy has different consequences. But kinetic can't be negative. It doesn't make any sense. What I usually do for script is capitalize bold, quantum, specifically enunciation louder, especially or suddenly. I mean, no, I can figure out myself. I'm just having trouble reading stuff in general, apparently. You see, I never graduated past 2nd grade in kindergarten, so look over there, opposite tense head proceeds to accelerate how fast in the speed of light. No, we can't accelerate, no, because then you're going back in time, and then on an imaginary axis. You're gonna get back to the officer. That's not gonna help. Fun fact actually about tachyons. Because of how tachyons basically exist in relativity, if tachyons exist, that means time travel is possible. Or at least if we can interact with them. Because if we can, they basically are going back in time. So if you have a tachyon, if you interact with it, you're basically sending information back in time, which is time travel. Fun fact! Why is the stream so off? How about now? How we look? There we go, 6,000. That's what I'm talking about. Attacking gunshots bullets into the past. Yeah, I mean, the one problem is that, you know, when it comes to tachyons, is that they're hypothetical. Damn universe. Oh, this is actually the second time I've said this quote, which I really like. This is the second time I've used this sentence in the video. This sentence won't stop us though, because we're not here to be reasonable. We're here to do math. So let's see what happens when kinetic energy becomes negative. We'll use two cubes colliding elastically. With each other on frictionless surface. And first we should see what happens with normal energy. So, first cube will have 1 kilogram. The first cube will have 1 kilogram and will be traveling at 2 meters per second. Second cube will have 3 kilograms and will be traveling at 1 meter per second. What happens when they collide? Well, when they collide, they just start going in opposite directions. Calculating those two new velocities is surprisingly simple if you consider that you need to conserve momentum and kinetic energy, and if we combine these equations we get this. Equations for both velocities, and if we follow them we get this. Yeah, I mean, looks pretty solid. But now, let's have some fun and let's give one of our cubes negative kinetic energy. Actually, we'll have to change up the ending of this segment. Tachyon's mass number is I, imaginary unit. That's what tachyon is, I think. Yeah, it's a hypothetical particle which has imaginary mass, basically. Tachyon. I don't know. I don't think anyone cares. I think it's with a Y, if I'm not mistaken. Let's see. Oh, I'm just that good and smart and intelligent. Theorized in 1967. Would you look at that? Power of imagination, you too can taste the exquisite taste of the tachyon. Taste the complex numbers. Play on Skittles. Okay. Wait, where did I finish off? I keep forgetting.
One of our cubes negative kinetic energy.
Negative kinetic energy, I see. Okay.
Negative
Kinetic energy. There are two ways to get negative kinetic energy, either negative mass or imaginary velocity, and imaginary velocity is similar to imaginary time from the first example, so boring value that's impossible to visualize. But the second way is possible to visualize, negative mass. So let's go back to our example. Instead of giving our first cube 1 kilogram, let's give it negative 1 kilogram. Now what's really cool is that we can just plug in our new values and get something weird. I mean, makes sense. Right here we have positive masses, so we get the collision. Right here we have negative masses, so the collision is going the other way. But no, something's wrong. I wanted to break physics using math. This isn't good enough. Why isn't negative mass breaking physics further? Right here in the script, we'll figure it out later, but that's kind of the conclusion of the video, so I'm just gonna say it now.
Breaking physics further.
Well, that's because each time with this... Well, that's because for each energy we put... Well, that's because for each energy we pulled a slight... No, let's try it again, make it, you can do it. Well, that's because for each energy we put a... I'm fine. Well, that's because for each energy we pulled a sleight of hand, and you see we kind of redefined them each time. For the photon, we just said that negative energy can exist because of the wavelength, right? So negative wavelength, which basically means that negative energy has no consequences. For gravity, we said that negative energy can exist because we just care about distance. We just care about the difference. Nothing broken there. And for kinetic energy, we said that negative energy can exist because of exotic matter. So matter with negative mass would have negative energy in this case. But hold on, how could we have all these negatives? But hold on, how could we have... But hold on, how could we have all these energies as negative, not nevergies or whatever? But hold on, how... I'm fine. But hold on, how could we have all of these energies be negative and yet still work? Well, that's because energies don't really exist. As I mentioned, I did make a video about this, but energies are more of a tool for describing the universe. So redefine the tool and all of a sudden it can be negative. But that's for negative stuff. Like exotic matter and negative mass. But let's go one step further. Let's go for imaginary mass. Okay, there we go. Yeah. Nevergies. Yeah. This Don't Skip series. Listen, if anyone wants to make shitpost videos, I'll be just glad to steal them and put them on the shitpost channel. We should do that as a real thing, right? You know? Any sort of clips anyone makes, I'm just gonna put on the shitpost channel. Should we make that a thing? Let's make that a thing. You know what? Let's vote on it. Let's do a democracy. How about that? I feel like we should do a democracy for it. Hell yeah, hell yeah. Okay, everyone seems to be saying hell yeah, so let's do it. Text poll. Since I do have a shitpost channel, here's an idea from one of the recent live streams. If you have any funny... If you have any make it shit posts, make shit posts, any make it out of context make it, dying for 5 minutes straight. Make it, but vocode it to the... I don't know. What other shitposts are there? I've just mainly been blowing stuff up. Sure. Headstack, I've already got a channel for that. You can't reinvent the wheel on this one. You gotta know when to, you know, quit whilst being behind, etc. You will be able to send them to a special the email or what, and if the council of make it deems it crap enough, it will channel. Should we do it? Yay or nay? Yay! Nay. Post. Every time make it as integrals on the channel. I mean, I feel like there are a couple of long-running bits which actually might make up at least a couple of minutes if you just cut them out. Every single time I say something is simpler than you think, or something is simple. Oh yeah, I should also take care of these polls. These are only the first rounds. I should extend them further. That's an integral! Oh my goodness, that's an integral! I love that moment. I feel like I could have done it better. The punchline, the delivery could have been better, but I really like that bit. Also, one of my favorite comments on the Addition to Quantum Mechanics video was when someone said, "Did you just teach me integration using probability and probability using integrals?" I think it's a great comment. It's one of my favorite ones. Alright, yay or nay? Let's leave it up for democracy to decide. Let's see, do we have any votes already? Yeah! 4 votes! Wow, crazy. Wonder where they come from. I feel so powerful making the poll 100% in my favor. I am the Senate. I can't make the voice. I'm not a voice actor. Alright. Me. Let's get some milk. Okay.
Let's go for imaginary mass.
Imaginary mass is way cooler than you think. So far, our experience with imaginary numbers has been meh. Imaginary time, can't visualize it. Imaginary velocity, can't visualize it. Imaginary length, we haven't gotten around to actually explaining it, but time dilation, it's just time dilation for length, so the exact same thing as the first chapter, can't visualize it. But mass is different and way cooler. First, in order to appreciate just how amazing it truly is, we need to ask us... First, in order to appreciate just how truly amazing it is, we need to ask the question of, why can't things travel faster than light? You may think that the answer would be, well, make it. If you go faster than light, then you end up with imaginary time, imaginary length, and all sorts of unpleasantries. But that's actually not the limit. Yeah, believe it or not, imaginary time is not the thing stopping us from traveling faster than light. What's actually stopping us is the energy. Allow me to introduce you to yet another relativity equation, an equation for the total energy of a particle. As you can see, for low velocities like the ones that happen from our everyday life to space travel, this right here is really close to 1, which means that this equation could be simplified as E equals mc squared, everyone's favorite. However, when we accelerate a particle more and more, the velocity becomes more and more significant, and one thing which you might realize is that the higher the velocity, the higher the energy. In other words, here's the energy of a particle at half the speed of light. Here's the energy of a particle at 75% speed of light. And as you can see, the closer you are to the speed of light, the quicker it's going up. And so, And so the more you'd like to accelerate the particle, the more energy you need, to the point where you need an infinite amount of energy to get a particle to the speed of light. But you already know there's an except coming in, right? So what this basically means that if we have this region in between 0 and speed of light, which are basically the speeds of our particles we can achieve, but now... No, this is not English again. What did I write down? Doesn't make any sense! How am I supposed to read this? Make a video called Fixing Physics with Math before he posts his power move. It would just be normal equations walking normally. Every single thing I mentioned in the video, except instead of relativity you have classical mechanics, and it's just normal numbers. Everything is just positive numbers. Positive real integers. Okay. Between 0 and speed of light, which are basically the speeds our particles can achieve. But now... So what this basically means is that we have this region in between 0 and the speed of light, which are basically the speeds our particles can achieve. But now, let's introduce imaginary mass and see what happens. If we introduce imaginary mass to our standard speeds, we get an imaginary energy, or in other words, add it to the list of things impossible to visualize. If we, however, try imaginary mass with speeds greater than the speed of light, then right here we get a number greater than 0, and so we get a negative number. And so we get an imaginary number, but... So we get a negative number, and so we get an imaginary number, but this time we can get... I'm fine. If we, however, try imaginary mass with speeds greater than the speed of light, then right here we get a number greater than 0, and so we get a negative number, and so we get an imaginary number. But this time we get both the numerator and the denominator, which means that we can just cancel them out and we get a real, normal, honest energy. And that's why imaginary mass is really cool. That's because tachyons, hypothetical particles with imaginary mass, not only travel faster than light, but have to travel faster than light. Whilst for our normal particles, the minimum is 0 and maximum is speed of light, for tachyons maximum is still speed of light, but the minimum is infinity. This would also lead to another interesting phenomenon in which you basically be able to send information not only faster than light, but into the past. So basically time travel. This time walking past travel. This time walking time travel, but that's a story for another time. So the question remains, why is it so hard to visualize any of these variables being broken using math? But mass is so simple. Well, that's because mass is not really what you think it is. So what is mass? Is it the amount of stuff? Is it the weight? Is it the difficulty to accelerate? Is it the interaction with the gravitational field? What is mass? Well, it depends. We generally call mass anything that depends on the amount of matter. Lots of stuff, lot of mass. Strongly attracted by gravity, lot of mass. Difficult to accelerate, a lot of mass. Mass is a term we created to help us describe reality. It's an abstract term, which makes it easier for us to calculate things for bigger objects without having to simulate all of the intricate ways in which particles making them up interact. And is sort of at the core of the big math versus physics problem. It's a common point of discussion to ask if It's a common point of discussion to ask if math is created or invented, but it sort of omits the true reason for why math even exists. All of science exists for the sole reason of being useful. The end goal is to describe reality in the most accurate way, and all different fields of science are tasked with creating that description differently. Math is trying to tell us what could be. Physics is trying to tell us what is. That's why we take what isn't but could be. That's why when we take what isn't but could be, it breaks physics. Breaking physics breaking physics in this case shows their discontinuity. Energy, for example, is just a concept. It's something we made up to describe how cubes bumping into each other behave. And since we only needed positive numbers to describe the sort of collision, we never bothered to invent negative ones, so negative energy doesn't really make sense. That all comes from the fact that energy as we know it probably doesn't exist. And to that you might say, make it, how could energy not exist? Of course it exists, we all have these fancy rules about it, but that's not quite the case. What is energy? Well, that question took me 26 minutes to explain last time, and the answer is not as simple as you think. The short answer would be, energy is a tool we use to describe reality, but it doesn't have to be real. This sort of thinking may confuse a lot of people really fast, because how could energy not be real? But we've already been in this place before. When you get introduced to classical mechanics, it makes sense. You know, mass, velocity, distance, time. But what many people will not realize that classical mechanics is an out-of-date theory and generally wrong. It's been replaced by relativity, for example, which we've been using mostly over this video. Relativity, which also doesn't have to be real. It's just the best theory we've got. When our energy is negative, math tells us what could be, but physics tells us that it's not. When our velocity is faster than the speed of light, math tells us where we would go, but physics tells us that we can't. When time is not only negative, but imaginary, math tells us that it could exist, but physics tells us that it doesn't. And that's why breaking physics using math works. Math tells us what could be. Physics is trying to tell us what is, and that's why when what could be collides with what is, what think that is, we break physics using math. Wow, that was a mouthful. Wow. That was a big mouthful. Okay, that's just a theorem. An Einstein theorem. Do you think if information travels in the past, it makes a new timeline? I've never actually bothered to get into timelines. It's actually surprisingly stems from quantum mechanics, if I do remember correctly, from the probability collapse, I think, if I'm not mistaken, but I've never bothered to get into it because it's a complex mess. Hi the cheese, by the way. Today we're going to find out why Billy ordered 5,000 melons and wanted to find the radio of a circle of melons against the area of it. They were going to be mathematically recreating imaginary technique called purple from the hit show George. It's actually where the imaginary technique name stems from. You know, it has imaginary energy actually. It's kind of like how people didn't use negative numbers because it was real. Now they are everywhere. That's actually precisely it. And then we went through the same thing with imaginary numbers. Quaternions didn't get that much backlash actually. Quaternions, people just realized they're useful. The reason why we use all of science is just for it to be useful. Things don't have to be real to be useful, basically. It sounds confusing, but it's true. So relativity could be wrong. It is, well, quite probable given our track record, but so far it is the best description of reality we have. Let's drink some milk. It's a warning for this? No, I feel like you've made it different enough that it's fine. Alright. Breaking physics using... now the next step is to animate all of this. That's gonna be so much work though. Fine. It's gonna be so much work, isn't it? Relativity breaks when trying to use it for describing black hole singularities. Everything breaks when trying to describe black hole singularities. We don't have a single theory for black hole singularities. That's what makes them so fun. The problem with black hole singularities is that basically it's a real life divide by zero problem. It doesn't make sense. And that's what's so lovely about them. Because, okay, divide by zero actually is not as mysterious as people think. It is mysterious, but in reality it's mysterious, but for a different reason. The reason why divide by zero is so cool is because divide by zero is basically infinity. So dividing something by zero is basically equal to infinity. The main problem is that it erases information. That's the main problem in math. So basically x divided by... So the biggest problem is x divided by 0 times 0. Like, these cancel out and you get an x, but technically x could be anything. But this is just... the reason why this is a problem, because this actually is more like infinity times 0. That's the big breaker. That's the big breaker of the universe. Infinity times 0. We have no idea what that's equal to because it doesn't make sense. Technically, this should be equal to any number, depending on how you look at it. So there are basically too many solutions to this equation, to the equation which should only have one solution. But when it comes to black hole, it's a divide by zero problem. No matter how you look at it, it's always a divide by zero problem where you get infinite values which from finite stuff. You get a finite amount of stuff, finite amount of space, and all of a sudden you get infinities. Which, yeah, doesn't make much sense. Just get paid 8 cents a day. It's fine, whatever. It's actually funny because for most of my live streams... hold on, actually, no, let me show you. It's gonna be much more fun if I just show you. For most of my live streams, it's a 4-digit number, but it's a 4-digit number the wrong way. Oh, let me find a video that YouTube already processed. It needs to be processed for them to... Oh, there we go. I just think it's pretty funny. They actually bothered to count it up. That's enough to buy 5 Big Macs a week. Yeah, 5 Big Macs a week is less than a Big Mac a day. That's not a lot of money. So... Well, recently I did something for Tefta and Tefta upgraded Patreon, so that's good. That's always good. That's always nice to hear. Bum bum. No, it's probably enough to buy a 1/8 pounder. Use real units. Don't use these pretend pound units, whatever. 0.4 cents. Yeah. As I mentioned, it's a 4-digit number, but going the wrong way. It's fine. I'm gonna get them one day. We just need to fake it till we make it. That's what I always say. Remember, kids, fake it till you make it, and that's how we get the big bucks. We just need to... I just need to scam people more often, you know? What do you define as infinity? Well, in this case, for example, the density, for example. Like, density of a... Depending on... Well, it all depends on the theory you're using for black holes, I suppose. Black holes are so extreme that when using different theories, they really do change. Like, on one hand, they have infinite density, because it's a singularity, of course. On the other hand, there's so many problems. Another problem is that it erases information, which is a pretty big issue. Another problem is the relativity problem with gravity. You know, how time and length dilation things, they actually not only get affected by velocity, but also gravity. And when it comes to singularity, it's a lot of gravity. Why is infinity times 0 not possible? Isn't it just 0? That's the problem, Oksana, because you see, here's the thing. Did my taskbar break already? Well, that was quick. Good job, Windows. You're breaking quicker and quicker nowadays, you know? The problem is that if you have a number, like for example, a divided by 0 is equal to infinity, right? And if you have b times 0 is equal to 0, then if you have infinity times 0, that's basically kind of like saying a divided by 0 times 0, or that's basically like saying b wait, times 0, so b times 0. Oh yeah, no, never mind, it actually breaks already on this step. So basically you can cancel these two out and you're left with a, which means that infinity times 0 is equal to a. The problem is that we didn't define the a, which means a could be anything. Which means that right here we get infinity times 0 is equal to 5, which is also equal to, I don't know, 7, which means that 5 is equal to 7. Math is broken and doesn't exist. Here's the thing, I mean, yeah. I could do a bit actually on videos. I might steal that joke. It's not a good one, but it's a dad joke, so I love it. Hi there, Krish. Do you make it? I'm explaining why 0 time. I'm breaking physics using math. I'm doing wacky maths. Wacky maths. So wacky. Haha. New video idea. Math is broken. Doesn't exist. Actually, I like the title. The title is just so aggressive. I love it. I might make a math is broken and doesn't exist. The problem is I would need to... Actually, not the worst idea. Just gather all of the indeterminate things and indefinite whatnot. I might do it. Will you even make a video about astronomy / astrophysics? Yes, I would love to make a video about astronomy, astrophysics. I might actually do it next month, you know? I've been looking for some videos to make next month and I've never gotten into it. Astronomy is basically the... Well, astrophysics is the field of physics which I know the least about, but I might genuinely do it next month. You know what, let me add it to the list of video ideas. Really cool. Make it, how many people are there in the council of Make It? Oh, that's redacted information. I can't share those secrets with you. That's... Ooh, that's only for the supreme member to know. Actually, the council members themselves don't know. Or maybe a council member. Or maybe there's no council. I can't give... Or maybe it's 1.5 or a -3. I can't share this with you. I'm sorry. That's above my pay grade. Stream, no, energy particles. Video ideas, there we go. There. Consider the topic added to the list of things which I probably will make. Rule 1 of Make It Cancel. There's no cancel. No, rule 1 of Make It Cancel is be nice and respectful to others. Rule 2 is have fun. Rule 2 is have fun and be yourself. I can try getting my friend the channel too. She loves astrophysics. I mean, if you know someone who's an expert in astrophysics, that would be nice. So far, my videos I've made with experts are much better quality-wise. I know nothing of it. I mean, I do know physics. You know, I just don't know much astro. How tough could that be? It's not rocket science. Well, it is rocket science, but it's only kind of rocket science. And I will use that to prove people have never written a wrong answer on my test. Math is just wrong, not me. Funny enough, actually, math is always correct. It's the only field of science which is always correct. That's because we basically define the underlying axioms and we just assume them to be correct. So if you're doing physics, you have the argument of, oh yeah, but physics could be wrong, so I could be right. When you're doing biology, you have the argument of, oh yeah, biology could be wrong, so I could be right. When you're doing any field, you have the argument of, oh yeah, that field could be wrong, so I could be right, except for maths. Math is the only field in which you don't have that. Infinity times 0 makers and the council of makers, yeah. such a wholesome council. Hopefully they don't start shooting each other, breaking time and sacrificing plastic bottles for hammers. We don't not gonna start doing that because we've already did it. I mean, not shooting certainly each other. Because actually, would that be illegal with consent? Well, I don't have a firearms permit actually, so it might be illegal. You know what? I would like to retract my statement. This was a joke, for legal reasons. The first live stream I'm enjoying is a nerdy live stream. I'm loving it. Every single live stream I make is a nerdy live stream, and every single live stream is enjoyable because I'm just this nice and cool. Math is always correct because incorrect math isn't math. Yeah, I mean, yeah. Make it. Do you do these live streams at the same time every day? No. No, it varies a lot. It varies. Sometimes I do them... Sometimes actually I do them like... Sometimes there's an hour-long gap between them. Sometimes there is a 47-hour-long gap. That's because of different time zones. But yeah, the only rule is one a day. It's not about time. Well, it is about time, except, you know, days, not hours. You know what? Let's import some animations because we have already some. We already have some animations ready. We already made some. Like for example, this. And this. What's your IP and MAC address? If that, you have to subscribe on Patreon. What's your favorite field of physics? Relativity, general relativity, no question. I don't even know it all that well, but I just love the idea behind it. I love the idea behind general relativity so much that it's my favorite field. This is the first time I haven't missed your live stream. Well, then I'm really glad you're here. I'm really glad I could make it for. I'm just really glad I could make it. I like making it.
Why does math break physics?
Oh well, what a convenient question, Pass to make it. I just happen to have an animation precisely set up for this very question. All right.
Why does math break physics?
Okay, well we can move you back a little bit. There we go.
Why?
And now it's time to time everything. Like this. Bow, 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 bow. To be honest, I love normal physics, mostly engineering, kinematics, force, whatever. Kinematics is really nice. Well, engineering is really nice. It's really nice. It's... When it comes to physics, there are two different reasons why people love different... Actually, for most of science, there are two different reasons for why people love different fields of science. It's either because of the underlying idea or if it's because of the practicality. So people either like to think about a certain field or do a certain field. Both of which I think are valid, in my opinion. What is the video you're editing about? I am editing about breaking physics using math, in which we'll do some wacky math or even wackier physics.
Why does math
break physics? Great question, Past Make It. Thank you, Future Make It. Future Make It can actually hear me. Hi, the Future Make It. Hi, Past Make It. I'm not losing my mind, by the way. I'm mentally stable. Thank you everyone so much for asking.
break physics? Okay, the process is simple, but I'd really like you to understand how we're able to break physics using math. And for that, we'll use a light bulb. This light bulb. When we turn it on... And for that, we'll use a light bulb. This light bulb. When we turn it on, it emits...
I should really add some sounds to my videos, rather than just me having them dry with music. You break down physics, but you break bad with chemistry. Just getting him really high. Hold on, do none of you actually... I mean, okay, to be fair, that's an early video, so you know what? I don't blame any of you for not seeing it, but I already made a video of the sorts, kind of. It's called... Medicine on crack? I'm sorry to say, but I already did the bit you're trying to... Yeah. I've already done it.
Hello everyone and welcome to a medicine video. Today we'll talk about very skinny chap. I can't do it, so tired. Give me a second. Hello everyone and welcome to another video, and today we'll talk about the integumentary system, which is the skin, hence the pun right now makes sense. The skinny chap, again, you get it. So, without any further ado, let's get into it, starting with the dermis, the epidermis, the dermis, and the hypodermis. And right away, you may think, make it, how am I supposed to memorize all of these different ideas?
But that's it, I already did that bit. Get into this moment when you're still small enough, you can see all the answers to your child. One day you'll be huge, and if you're still doing live streams, they'll be completely filled. It's really nice, actually, would say. Well, for me, it's really nice to respond. I don't know, maybe in the future I'll do, even if I'm big, I might do just chatting live streams, which I just sit there and chat, and that way I probably could be able to answer every single... I mean, there are a lot of messages which aren't really made for me to answer, so... You definitely high when recording that. I wasn't... Okay. As I mentioned at the very beginning, the only psychedelics used were caffeine and music from La La Land, okay? And we fight to the death. It's interesting that I think you'd stand a chance. Anyhow, I'm surprised Make It isn't huge yet. Well, can't you see me in the corner? I would say I'm pretty big. Like, come on! I would say I'm pretty big. Whatever. I guess different people are different. We just draw on, I suppose. But yeah, in my opinion, my channel is still massive. In my brain, I still have 500 subscribers, so... I think you have a green screen, but I decide to use it as a background. What am I supposed to green screen the background? I got a green screen. To be fair, okay, I am really frugal. I got that green screen for free. That's how good I am at making deals. Have you only rendered that one light bulb and text so far? No, I've rendered more. No, that's the wrong order. There we go.
Photons, or in other words, light.
Wait, why are they just different? Oh no, hold on now. Oh, I see.
Light.
This is fine.
More photons, brighter light bulb. Less photons,
This
lower
is
bright.
for different times. There we go.
More
photons. Wait, why did I stop the music? That's why it feels so dry. There we go. We're back. Ooh, you okay, cheese? Yeah, but if you have like 5,000 people, you won't be able to answer everyone. Zentre, you might, if you actually check the messages in chat, you're really careful, you will see that I omit a lot of messages. Because as I mentioned, there aren't all that many people who actually chat in the chat. Like most messages, there are two kinds of messages I omit. The first one is the reaction message, because, I mean, obviously it's just the reaction message. It's not really meant to further the conversation, it's just meant to showcase the reaction of the person. And then there are a lot of like things which I just refuse to read. What's the name of this song? I don't know, I haven't named it. Odd Kid 2. Oh yeah, it's Odd Kid 2, never mind. It's Odd Kid 2. It's the grooviest song I've got. I mean, it's great. What live stream we need to past 5,000 views though? That is a good question. We might not get to 5,000. But you know what? I don't care. I'm having fun streaming. I mean, I clearly don't care. I've been doing this for what, 560 days now? I clearly don't care. I think we've settled that. What live stream we has 5,000 views though? Future make it probably.
More photons, brighter light bulb.
Less photons, lower brightness. Simple. We can represent the amount of photons emitted. Less photons, lower brightness. Simple. We can represent the amount of photons emitted with a number, so this would basically be... Make it viral, I wish. Oh, if we could only get another addition to quantum mechanics, am I right? Oh, the adventures we could have! I discovered him from addition to quantum physics. Yeah, precisely what I mean! Everyone discovered me from that video. It's my only video! Oh no, never mind, now we also have the 7-dimensional one. At one point, that video was responsible for 95% of the views I had on the channel. 95% of my channel was that video. If you look for popular, it's really funny. You basically get... Before this video, it wasn't even grading up, but you have 400,000, and then 46,000, and then 12,000. Before 2 weeks ago, this was just a massive gap. Yeah. Video that I'd actually recommend. 9 Symphony. I'll be so sad. I mean, yeah. As I mean, it's my only video. From YouTube's perspective, I made precisely one video, and it's the addition 1.5. The 7th dimensional one is also doing alright. I've been posting everyone I know to subscribe to make it. Discord, the IRL school, everywhere. Terry, that's respectable. Give that man a drink, pour him a cold one, and salute. Is that spelled Oddkit 2? You won't find it anywhere. I generated it. Say I generated it. I'm also about to binge watch the whole channel. I mean, the old videos I wouldn't recommend. The old videos suck. And in this case, I don't mean like, oh no, modest, my video. No, the old videos really do suck. The problem is that physics in science general is not a popular topic because people like basic entertainment over teachable entertainment. I wouldn't say so. You know what? I mean, I don't know. I feel like, I mean, I guess you should define, you know, what you think. I guess you should define popular in this case, but the easiest example at least is Veritasium. To be fair, Veritasium is more focused on entertainment than education. But there is a lot of education in here. As you can see, each one is getting millions of views, which is pretty good. Then you have, well, Vsauce. Oh, another Nile Red actually. This is this is a lot of education. To be fair, it's also entertainment, but clearly working out. Well, Kurzgesagt. There's a lot of people who don't like Kurzgesagt, but I like him. I feel like, yeah, they're clearly going for entertainment too, but at the same time, the... where is it? Well, first of all, the social videos are pretty important. They share an important message, in my opinion, so that's great. And second of all, their videos about the immune system are incredible, and viruses. Honestly, I feel like biology-wise, it's really hard to make a video in a better way than Kurzgesagt does it. The physics, okay, there are a lot of videos which are silly. Surprisingly, this is not a silly video. This is a surprisingly solid video about relativity and black holes. The thumbnail is off-putting, but yeah. There is a lot of silly videos, like, you know, blowing stuff up and whatnot. But they know what they're doing. Free Blue and Brown might implant. Oh hell yeah, Free Blue and Brown. Of course, Free Blue and Brown. I was getting actually to Free Blue and Brown. Free Blue and Brown is obviously absolutely greatest of all time. No better math YouTuber than Free Blue and Brown. I make my students watch your videos when I need to explain the basics to stuff right. I'm trying to say that I can't understand how people prefer like gossip over teachable content. Manuel, I feel like you're falling into a perception trap in there. You see, gossip is much louder than scientific content, that's true. But it doesn't really mean more people enjoy it. It means more like more people are exposed to it. When it comes to people who make just gossip videos, then yeah, they get a lot more views, but they don't really have an audience. They just have people who got clickbaited into watching these videos or are watching these videos out of spite, anger, or whatever. So I wouldn't really say that gossip videos they're getting more views, but that doesn't mean much. When it comes to actually science-based videos and, you know, videos more about education than gossip, what you will find that is that the community when it comes to those channels is much, much better. Usually the most subscribed channel has the most dumb stuff, I guess. I love Fruit Brown. Yeah, Fruit Brown accepts that, escapes that, but at the same time, I wouldn't say so. No. I feel like it goes the other way. I feel like simple channels certainly do get, you know, higher subscriber counts, but if a channel gets popular, there's a lot of different channels that actually manage to keep up their specifics and their style, their source, if you will. I'm making videos more Java Science channel and Science Click. Let's see then. I'm gonna go for Science Click English since that's the language I speak. Oh, I actually seen that. I mean, no, I haven't seen that video, but it's popped up for me. And I think this one too. Looks pretty solid. I mean, okay. I really like the topics. Also, this video popped up for me. Yeah, I really like the topics for most of these. The how to store data on DNA seems a bit simple for my liking, but the physics ones I absolutely love. Yeah, I can't rewatch them on stream because that's content stealing, but it's like asking for money versus building a good company. Precisely, yeah. And what you will find is that companies is actually the same thing. When it comes to companies, you do have companies which make a lot of money and they're really loud, everyone knows about them. But at the same time, you have a lot of good companies which actually care. And even though they're not getting as much press, people who use those companies absolutely love them. So a good example would be... Oh, I almost said Google, but no, I love Google. I love Google, my beloved. Please give me more impressions on my videos. A good example would be Meta versus Cloudflare. So Meta is a big company that doesn't really care much, and Cloudflare is amazing. I mean, everyone loves Cloudflare. So far, every single serious networking professional I've talked to absolutely adores Cloudflare. It's great. And why am I pronouncing so weird? I sound like I'm drunk, don't I? Oof, that's weird. I think we'll have fun with both custom and Vsauce. For example, so yes, I feel for biases. I mean, yeah, it's a typical loudness one, because gossip is way louder, but it's louder in a very meaningless way. It's easy to get caught up in the gossip. That's obvious, but when you get caught up in the gossip, it's very light most of the time. Wait, you're not drunk? Yeah, I actually don't drink. Would you believe it? Well, I drink, but not alcohol. I have 2 liters of vodka in my office, and I don't even drink. I have to leave now, but I hope I can catch the live stream tomorrow. Well, Biden's entry, and have a good day. See ya. When you're good enough in maths, you're drunk by default. Yeah, I don't need to drink, I do science.
Give me 1. This would be 7, this would be half, this would be 100.
Oh no, I'm saying things really quickly. Why did I spend so much time rendering all of those and I'm saying them so quickly? Look how long each of these animations is. I really do sound drunk, don't I? Okay, this. Oh, look how long all of them are. Damn it. I wasted so much time on rendering them.
Be 1. This would be 7, this would be 1. This would be 7. This would be 7, this would be 7, this would be half, this would be 100, and so on.
Yeah, the 100 gets pretty bright. It's 100.
Now what we've done is we just abstracted a real physical thing into this number.
Hold on, did I skip over something? Yeah, I did. Yeah, I did.
Abstracted a real physical thing into this number. Just is we just up.
Oh, the nuclear explosion on screen, lovely. I've got the name of that really hard integral. Gaussian integral? You mean the Gaussian one? Drunk Newton. I feel like physicists aren't drunk, you know? No. Physicists aren't drunk. Physicists are high. In order to invent physics like Newton did, like Einstein did, you need to be high as a kite. To be fair, Newton wasn't smoking all that much, but Einstein, his dealer should get a Newton Prize, honestly. Should get co-credit for all Einstein's ideas. Because in order to invent something like relativity, you need to be smoking something serious. Is it bad I only recognize math stuff by what looks like, not by what it's called? You're just missing a name. Names are just labels that we use in order to, communicate easier.
What we've done is we just abstracted a real physical thing into this number. A big word because it's kind of important for the whole process.
I can't believe that actually we've recorded this on this stream. Wow, how convenient. It feels like I did yesterday. I can't tell if I'm falling asleep or if I'm just tired. Or if I'm uncaffeinated or whatever that word would be.
Well, yes, all of them.
Oh, vocal enhancer make it. Welcome back, you sexy thing. Albert Einstein used to think of relativity during his coffee breaks at work. I mean, yeah, like... listen. Just thinking of someone falling and then realizing that falling is basically the same as being at rest and everything else going up, accelerating upwards. It sounds obvious to everyone who, been over relativity, but in order to think of it for the first time, when all of physics up to that point basically thought of gravity as, well, you know, things falling down. Thinking of it as being at rest is insane. At least in my opinion.
Abstracting it important? Well, it's because now there's a number, we can do all sorts of things. Now there's a number, we can do all sorts of things, like normally setting it to normal stuff like 1 or 0.5.
I'm convinced that all physicists are mathematicians, just drunk people with a liking for complicated stuff. No, Terry, you're wrong there. You see, physicists are high, mathematicians are insane, chemists are drunk, okay? Doctors, it depends. Doctors are either extremely healthy, or when they're like researchers, right, medical researchers, then they're over-caffeinated, which is so boring. And biologists just don't exist. No one cares about them.
But wacky values, like
Wacky values, oh how silly.
0, which
It's wacky values. It's Wacky Value Wednesday. Wednesday during which
0, which gives us
we have wacky values. The values are wacky.
there's no emission, or negative.
-1. I could just press Ctrl I. I know where I'm going to the thing each time.
-3. What would -3 mean? Well, for blender it's simple, just darkness. A light bulb so dark it's sucking up all the light. Darkness. A light
I think biology wasn't for the long names. I don't know, I feel like if you want to flex your knowledge using names, I feel like you should go for programming. Programmers have an ego, and that ego demands long and complicated names for simple things. I'm pretty sure they call it doing maths because it's actually a drug.
bulb so dark it's sucking up all the light around it, but for real life, it doesn't make sense.
Right here we'll have just like a 3D make it problem and confusion. Oh, it doesn't make more word to me.
It doesn't make sense. And that's the point I'd really like to accent in this case. If this value is the abstraction of the amount of photons an object is...
Okay, now we can render some more stuff. It's funny enough, we're rendering it with negative brightness, which makes the renders relatively slow. Bum, 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 ba, ba, bum, 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 dum, dum. Breaking physics. Initial example. There we go. Now we can set back abstraction, and then you'll see that as we render it, it's going to be pretty wild, because this is an extremely bright text on a, well, to say pitch black is say nothing. This is negative brightness. I can understand how biologists and zoologists succeed to understand platypuses. That is a good question, isn't it? I myself think that platypuses aren't real, honestly. I feel like that's just a part of government propaganda to get us thinking a certain way they like. I don't think platypuses exist. Have you ever seen a platypus manual? Like, in real life, in the wild. Not in the zoo, because they're all fake there. In real life. Have you ever seen a platypus? Platypus? Harry the platypus? No, I can't. Refuse. There we get a blue light because our negative brightness is yellow and negative yellow is blue. Alright.
Abstraction of accent in this case. If this value is the abstraction of...
Now we can just dip it back.
The abstraction of the amount of photons an object...
And this one, start of cut.
is the abstraction of the amount of photons an object is emitting, then negative value wouldn't mean the object's...
And right here we need a photon getting sucked up. So a yellow ball getting sucked up by our light bulb. 650. And we're gonna start right here. We're gonna keyframe you, and then we're gonna have you move into the darkness. Actually, no, into the light bulb, I feel like would be better. Has a backwards right. Dr. Doofenshmirtz, yeah. Oh, could have just asked me. Alright, let's make it yellow. Like this. In order to get perfect yellow, we divide by 6. And what's really fun is that this is -3, which means we would need it to be quite bright in order for it to actually shine through the darkness. So let's set it to 30. And I'm actually really curious to see what it will look like. Because it will be basically a battle of two titans. The light bulb with, well, ironically named light bulb, considering that its brightness is -3. Let's see. For some reason I felt maybe I could pull off a good Dr. Doofenshmirtz impression. The prophecy has been fulfilled. Do Germans even know how to read their own name? No, they actually have just a random letters generator, which they use to create their names. You can see how long each frame takes to render. And this is 100 frames. This is gonna take a while. This is the longest riff on the guitar, and just like that, the music's switched. Whether even part of the picture, yeah, the legs, if I remember correctly, and the pipe. I remember the pipe. I think Blender is genuinely just rounding up the values, and I find it comical. Okay. There. Consider that photon sucked up. Render time.
Help!
Oh. It takes fucking hours to finish its purpose of rendering. I mean, it doesn't. Well, it does take hours in this case, actually. It's around 120. Yeah, it'll be around two hours to render. Yeah, see you, Mike. Alright. What do now? We've set up the video render thing. Just wait for it to render. Pose. Let me check something real quick. Is rendering computer analyzing which pixel exists or not? This is ray tracing, which means from the camera for each pixel you get a certain amount of rays, and then the computer simulates where these rays would go. So you know how light is basically different wave particles going and reflecting of different things? Blender is doing the same thing. Are all of these songs AI generated? Yes. All of them. Yeah. They're really good. I need to explain my grasp point because I never understood them. Oh, isn't that the Newtonian physics upgrade, basically? I don't know them all that well. I would need to research them. Points. In celestial mechanics! Oh! That would tie in pretty nicely with the next month's astrophysics video then. Lingering points liberation. Well, almost a good name. Points of equilibrium for small objects and the gravitation for two massive orbiting bodies. Mathematics involves solution to the free body problem. Oh boy. Maybe. Maybe next month, we'll see. We'll see how things go. If it will see prototypes of industrial robots in a lifetime. Depending on the definition of industrial robots, we've seen them for a really long time. Do you mean like general purpose robots? Where you just make the robot and you can then do with it whatever you want? So you just make a robot and only then say its task. Because those probably won't happen for a while, but not because they're that difficult to make, mostly because they're impractical. It's much more efficient to make robots for a specific task than it is to just, make them. You know what? I feel like that will be kind of it for this live stream. I have a chemical reaction to do actually today. I'm going to do a chemical reaction for a video and hopefully record it. Well, ideally recording it as a video, of course. A fun one and one that I've never done before. Well, not a fun one, but a one that I've never done before with equipment I've never worked with before. Today is gonna be a test reaction, tomorrow is gonna be a full reaction. The full reaction will be much better. Do autonomous vacuums count as robots? I think yeah, I would say so. make it equals 9, reconfirm. No, don't spoil it for everyone. Anyhow, for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye.